Alright, this is a vacuum oven, which is on my front porch. I mean, doesn't everyone have one of those? Problem is, the Omega CN76000, those are not working. One of the problems is they die when it gets cold. And guess what? It's on a porch, so even here in Florida, they get cold. Anyway, first step is to get those. Actually, the first step is to open up the side panel so that we can get at them. Internally, these two bolts or screws and these two hold a solid state relay in place. These two are fuses for the solid state relay, which is running on 220, and this little fuse goes to the Omega, and I'll use the same fuse for the Inkbird. But let's get it open first. And this is the way you remove screws. One. Let's go with the bottoms. Two. Sheet metal screws. Yay. If you haven't done 1,000 of them. And the last one. Okay. Well, looks like there's spider webs inside. And also, it's a nightmare as far as reaching things is gonna go. Well, okay, it's unplugged, so the power is definitely off. Okay, top one is gonna be more of a problem than the bottom one. Slightly different units, but there is the thermocouple. That is on one side. The other side coming in is the power line, and on the bottom of the box is a little toy that will help it to even out power fluctuations. Alright, let's work on the bottom one first, because that one seems to be more accessible. Now, one of the nice things about these guys is if you push in the middle, take the unit out. However, that does not change anything about getting these out. There's a 4-way clip, which is a bear. They've got a tool to do just exactly this, but I don't have it. There's a trick that you use where you use a little bit of diagonal, and then you can pull it out. Not going to take it all the way out, but I wanted to point out, first blood, these are always in awkward locations, okay? Always. So, what we're going to do is, there are 2 screws down here. I'll take those out. One. 2. That removes the power. Awkward. Here we go. This is the thermocouple. Come on. Of course, you can hardly see anything because all the angles are bad. Well, not going to slide out, is it? It would be too easy if it did. Power on the back side. Ooh, hitting my chest. Ho ho! Come on, Omega. Work with me, baby. Wahoo! Yeah. Well, that'll make it a little easier. Let's look at it from the other side. So there is 1 and 2 going to the solid state relay. And according to this, '13 and 14 is line in. Sensor inputs. Okay, so those are the sensor inputs. Output A, output B, fine. But we are looking at 1, 2, 3, 4, 5, 6, 7, 8. Output A. Well, before I release output A, one of which is going to be positive and one of which is going to be negative, I have to figure out output. Okay. Solid state relay. Five-volt logic for voltage. Oh, there's class 2. Well, it just does not say. Okay, well, I'm going to have to go get the manual before I take that off, because otherwise I won't know which one goes where. Okay, I have verified that the top one is number 3 and positive, okay? And people wonder why I, as a guy, have nail polish. There you go. I have marked it. Won't make any difference because it's on the inside, but blue is for boys, okay? Now, having marked it, we can now take it off. Yay! Man, that is on there. Almost like someone didn't want it to come off. That is the narrow driver. And again, I'm only going to do one at a time. So it's going to come out. Or is it on there with a loop? Wow. That was a moose when I put that in there. Come on. Come on. Universal Screwdrivers EA. Yeah, that's in there. Daddy didn't want that come loose. Man, they're made for elves in the Black Forest or some such nonsense. Very, very tiny, and the screwdriver just barely fits the slot. You can see on that one, I have the mark. That's all well and good. Okay. As for this one, man. It's a thermocouple. Much easier to recognize, okay? Normally I would just, if I was just going to replace it with another Omega, take it out, put the next one in. I wouldn't have to mess with any of the wires. But there's two problems. One, I'm replacing it with a different company's product. And two, yeah, this has been in here for over 20 years. So it was put in by me, who said, I will never touch this again. And had the price on the stupid Omegas stayed reasonable, that would indeed have been the case. It looks like I've got them. And, oh, you bugs. Well, is it a spade? Yeah, why didn't it not come out? Well, for whatever reason, quarter turn off. Yeah, well, that will be going in the trash. So now we find out how good, and see, it's a quarter DIN, which is the square size. So, is that going to fit in the hole? Darn close. It'll fit. Not looking forward to taking it out if I have to. It's easier to work outside the box. That's the way I think. And those two have loops on, which is why they were bugs to get off. Ah, such great big fingers. Now, the number 6 terminal should get the one with the blue paint. Verifying that's the number 6 terminal. The number 6 terminal. Again, you need 9 fingers to do this. And if I was clever, I'd have just clipped it, rerouted a bit more wire. But no, I'm trying to do this without adding any more wire. Okay. Verifying. That's got the goopy one. Yeah, that's the painted one. Okay. Oh, look, modifications are possible. Now we have a spade lead, which, while it might be a little bit less intense, it's exactly what I need to get in the slot. Because now what I can do is start the stupid screw. You know what I maybe should do if I was going to do 1,000 of these? Is get like a magnetic screwdriver. Yeah, that'd be fun to play with. Alright. Take it up just a little bit. There we go. And that one, that's good. So what we'll wind up doing is sliding that through the opening and clipping on from the back. Now, what I'd also like to do, with the red and the white wire, the red is negative and the white is positive. That will be my thermocouple connection, and that I'll be able to get pretty easy because it's on this side. But this one and this one, double uggle, are power, and they're set to go all the way to the back. Now, just stab myself again. Alright, let's see if we can get them. That one seems to be a little bit more accessible. So let's take the screws out and see what we can do. Like that. And like that. This would be much more difficult if I was trying to do it inside the box. But if you have difficulties, please know you are not the only one. Come on. There we go. Is it even in the hole? Come on. There you go. Oh, it'll be very frustrating to strip that screw. Now I do have a spare Inkbird unit, but I would rather save it. Tight. Ah, there we go. Just no wiggle room on this. Okay. That is the thermocouple. And that is the other lead coming in. Huh. Well, let's modify it a little bit more. And then squeeze it. Oh, like that. And let's take that one all the way out. Worst case scenario, there's a couple of spares on the other side. Ah. Okay, that's in. And, well, now this is going to wind up being on this side. So all of these lovely little details are best done now. These are very annoying to have to get at, but that's the way it's going to be. All right, yay! Did I catch them all? Uh-huh. side. Yes. 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 Oh. All right, let's change camera position. Okay, let's get that in place. There's the lock. Slide it forward. Listen. Yep, it's locked. A little bit loose, but we can deal with that. So set screws to hold it in perfect position. That's actually pretty darn tight. Okay, now I'm going to show you why you look on both sides. Yeah, I just installed it 90 degrees off. So I back it out. So let's do it the right way. That is the way we want it. Get in there. Pretty? Pretty enough. Now, this locking ring, I want it to go on that way. One, two, three, four. Still got 4 wires attached, which is what I want. Okay. It's the correct way up front. All right, you listening? I can get one more click out of that. That was a very soft click. It's got those set screws, and that will tighten it up if I need. Yeah. Okay, that's good. Now, the final thing is the thermocouple. Those are already spayed. Red is the negative, and that goes to 3. The white is the positive. There's never enough room to do this nonsense. 1, 2, 3. Red is negative. It's got all this lovely insulation. So when I'm done here, I'm getting a shower. Okay. Negative is red, is number 3. Yeah, I'll say it 3 or 4 times. Positive is white, is number 4. Of course, it's not gonna go in easy because fighting is what it's gonna. Oh, it just slipped in. Okay. Let's use a Phillips end. Just so you know that the level of frustration is pretty normal, and that's why technicians get paid the big bucks. The engineer has to figure out what you're supposed to do, and the technician's like, okay, that's what the boss wants. How am I gonna do that? That's tight. And that's tight. Moment of truth. We're going to plug it in. See if the universe blows up. No, nothing blew up. Power to the unit. Nothing, honey. My gut feeling is we have a bad fuse. So let's try stealing a fuse from here. Can't tell. We'll find out. Okay. Power to the unit. Nothing, honey. Well, I'll just have to get another fuse. All right. Fuse box. Box of fuses. Get rid of that one. Put in a new one. Yay. All right. These two are the big fuses. Those go to power. Okay. That's looking correct. So, we at least have power to the unit. Its set value is 50, and up here it's reading 19.7. However, that is set for a K-type thermocouple. So, I believe. All right. Now we've got one more unit to do. I will unplug the master power. And we will work on that one on the top. Oh boy. Now we've got both of them in. The second one was a little bit trickier, but we got her done. So, what do we get? Yay! Now the first one. It says it's 21.1 degrees. That would be centigrade. And the little red dot here says there is an output, but nothing is happening to the output because I have not turned on power to the output. So, let's see if it controls anything or blows fuses. It's set for 50, 23, 25. Well, it's doing something. I don't want it to heat up too much. Okay, so the heater is working. Now, it's a Type K thermocouple that it's set for initially. That's the factory setting. Let's see what we can do about that. Now, we mechanically put the wall back in place. Otherwise, there's going to be, Minox chewing on the power cables. Never tighten it on the first pass. If you don't know why, try tightening it on the first pass, and then you'll know why the second time. Come on, where's the hole? There's. Done. Let's adjust some things. it's currently running on a, it believes it has a type K thermocouple. It actually has a type J. That doesn't matter. I'm going to press the set button for 3 seconds. Okay, now it says 1P, which stands for input settings. Okay, and that one, SN, which stands for input type. And that funky little thing is a K type. And not what we want. But PT, not what we want. S, T, E, there's J. Now, down arrow will take us to the calibration display. Set. Takes us to the calibration. That's fine. It's DL stands for digital filtering. No, we'll leave it at the standard factory setting. ALP is alarm setting. The one that I just jumped over was the output setting. None of those matter. Okay, the next one is PID. Okay, I'm going to go with the factory settings, okay? They're usually pretty good. You might want to adjust them, but that's okay. Now, unit temperature. Okay, let's find out. It says it is reading in degrees C. That's what we want. Okay. And now we're back out to the base menu. All there was to it. I changed it from a type K thermocouple to a type J thermocouple. That's all I did. The rest of them, factory settings. Alright, now then, let's see what happens when it tries to reach 50 degrees. I just turned the power on. I mean, now this little red dot says it's controlling, saying do something. What it's doing is back in here is a solid state relay, and it was sending the control signal, but as long as the power was turned off to the solid state relay, the power was not getting back inside to the heater band. Now it's getting to the heater band and it's driving the temperature up. Not unexpected. Is it gonna get there? At 45 and 46. It's still sending straight power. The heater band effectively is plugged in. I wonder how far it'll go. Up. It turned off. 49.50. It turned back on. It turned off. It's doing something. 50.1. 50C isn't that hot. And you see now it's proportioning. What's happening is the load is being heated. The heat is saturating into the metal and whatever's on the other side of the metal. It's going to absorb a lot of heat. Let's see if it goes over 50 this time. I mean, 48.9 degrees, 49.0 degrees, and now it turned off. It's not sending, there it's sending heat, Now it's not sending any heat. It's still heating up, but that's the lag between the heater and the thermocouple. Now it's still learning what the load looks like. There are different kinds of loads, and it doesn't know. It's simply doing this from trial and error. Imagine if you had your sensor 6 inches away from your heater. Well, it's going to take longer to heat to that sensor. But the point where you're putting the heat in might go way over. Imagine you have your sensor, your thermocouple, literally touching your heater band. Well, that would respond differently. It doesn't know what you're running. But by doing some experiments, which is what it's doing, it learns. Okay, now it turned back on at 47.7 and it's flicking. So what it wants to do, it wants to send a proportion of heat. And I have it set at 4 seconds. That's the factory standard, which is okay because it's a solid state relay and they do 100 million cycles before there's a problem. They just don't burn out. Well, they do, but only when you abuse them, and this is in a nice, comfortable environment. Okay, now it's staying at 50. That's where its target is. It's 1/10 of a degree over, 2/10 over. Not feeding any. Oh, it just gave it a little flash. .4. Now it's proportioning the amount of heat that it gives. Yeah, it's playing games, it's learning. So for the first 15 minutes, let it do its thing. It hasn't fried the plastic. Years ago, I was working for another company, and I came in and I said, "Oh boy, you've burned the plastic." Like, no, the temperature, it says perfectly right here. And I looked around, and literally they had a drying pot like this. The thermocouple had fallen back, and it was 6 inches away from the insulation, and the insulation was at 500 C because it was full speed, and the radiative heating was all that was reaching the thermocouple. Let's just turn this off and wait a few hours. And literally, I ignored it for the rest of the day. And in the morning, the next day, came back and opened it up and looked into the bottom. And there was what we call a Texas pellet. It was a plastic biscuit, 8 inches thick and 8 inches around. And it's just, that's not going to be fun. Fortunately, it was acrylic. And the technician I was working with was like, "Oh no, what's going to happen now? This is going to take years to clean. Oh no." You're paid by the hour. What do you care? It's like, no, it's not going to take that long. It's going to be fine. And I took some rubbing alcohol, opened it up, and poured in an entire plastic bottle of rubbing alcohol. And so just ignore it for a couple hours. We came back, and I hit it with a tamping bar, and all of that acrylic shattered. Do not hit acrylic with rubbing alcohol. It's a bad idea. It crazes. It causes all kinds of cracks to form. Well, that's exactly what happened. And the cracks followed forward, and All I did was go tap, and the cracks went through, and we took a shop vac and vacuumed it out, and the whole chore, you know, $1 for the rubbing alcohol, and ignored it for a day, so there's no time there, and you know, all we had to do is empty the debris out of the shop vac, which probably I should not have run rubbing alcohol into, but the alternative would have been to have my poor technician spend hours and hours cleaning out this stupid plastic. Now, how did I know that that would work? Because I've got good judgment. How do you get good judgment? Well, you get it from experience. How do you get experience? That comes from the bad judgment. And whenever you have a case of bad judgment, just say, well, I'll know not to do that next time, because you've just gotten from bad judgment to experience. There's where you get your good judgment. Yeah, it's trying to dial it in. It's staying closer. You really want to break its brain? Not that it has very much brain. What you do is you open up the vacuum chamber and throw in 50 pounds of plastic pellets, and then you seal it up. Well, now the load is different. It's trying to suck up heat, whereas before it was just an empty volume. So it heats that up, but what happens to the pellets in the middle? Well, they don't heat up as fast because they're farther from the heater band. So yeah. So you go in after a day and stir them if you want, or leave them for 3 days and ignore them. How do I know to do that? Good judgment. Well, the plastic heater is now working. I have replaced both of these. So I will set it to the correct temperature when I load the plastic into it, and we will go from there. Let me set it. Now, it's flashing at you. It'll do that for a minute, and then it will time out. Or you can push the set button. I have just said, no, I want you to go to 60 degrees. And it will do what it can. However, I'm going to call it quits for the day. I'm not going to do anything with this for a couple more days. But the beast is fixed.